Hey, welcome back, students. Welcome to Chapter 5, Trigonometric Identities. Let me share my screen. Okay. Okay, fundamental identities. Okay, we have Pythagorean identities. Okay, sine squared plus cosine squared equals 1. Okay, tangent squared plus 1 is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Quotient identities is tangent theta is equal to sine theta over cosine theta. I think we've talked about that one before. Cotangent of theta is cosine over sine. So keep in mind, tangent is like y over x, and cotangent is like x over y. Okay, cosecant is 1 over sine. Secant is 1 over cosine. These are reciprocal identities. And cotangent is 1 over tangent theta. Okay, even and odd identities, the sign of a negative theta is the negative of sine theta. So we would say that that's an odd function, okay, because the negative comes out. The cosine of theta, of negative theta, is equal to just cosine theta, so they're the same, regardless of whether theta is negative or positive. We call that an even function. Tangent of negative theta is negative tangent theta, that's an odd function. Cosecant is, this goes back to sine. Okay, so since sine is odd, cosecant is also odd. And secant behaves like cosine because it's 1 over cosine, right over here, 1 over cosine. Okay, and so secant is going to be an even function. And cotangent, it behaves like tangent. And so cotangent, negative theta is negative cotangent, so that's an odd function. So it looks like only cosine and secant are even functions. Okay, it says, note, the fundamental identities can be used to find trig values. Remember to choose the appropriate sign of the trig value depending on which quadrant of theta you're in. Okay, so make sure you know which quadrant you're in. Okay, given cosine of theta is 5 over 8, and theta is in quadrant 4. Okay, so what does that mean that theta is in quadrant 4? It means that if I were to draw a graph and have my angle here, then theta, okay, being in quadrant 4, means that cosine is opposite over hypotenuse, or sorry, is adjacent over hypotenuse. And so the adjacent side is 5 and the hypotenuse is 8. That means that my opposite side here, okay, or y in this case, okay, is going to end up being a negative value because it's in the 4th quadrant, okay, and y values are negative in the 4th quadrant. So keep in mind that this guy is a negative, okay. It says find the sine of theta, the tangent of theta, and the secant of negative theta. So we're going to use Pythagorean theorem here. Okay, they do give me the cosine of theta, and so we can find the sine of theta by going sine squared theta plus cosine squared theta. Was it? Yeah. Cosine squared theta is equal to 1. So sine squared theta plus, we're going to use that Pythagorean identity for sine and cosine, plus 5/8 squared is equal to 1. Okay, so sine squared theta is equal to, plus 25 over 68, or 64, sorry, is equal to 1. Now I'm going to subtract 25 over 64 from both sides. And this 1, I can make it a 64 over 64. Okay, so that 1 becomes a 64 over 64. And 64 minus 25 is 39. So this becomes 39 over 64. And so the sine squared of theta is equal to 39 over 64. So now what I do is I take the square root of both sides. And I say that the sine of theta, okay, is equal to plus or minus the square root of 39. I'm going to take the square root of the top and then the square root of the bottom. The square root of 64 is 8. So this is sine of theta is plus or minus. However, we do know that the sign is in the fourth quadrant is negative. So we're going to take the negative value, not the positive one, and we get negative radical 39 over 8. So that's the sine value. Let's do the tangent value. Okay, so the tangent of theta, okay, is going to be equal to the sine of theta over the cosine of theta. Okay, and so the sine of theta we just found to be negative radical 39 over 8. And the cosine was 5 over 8. Now if I multiply both top and bottom by 8, I can cancel out those 8s. And so this just becomes negative radical 39 over 5. Okay, what about the secant of negative theta? Well, the secant of negative theta, okay, secant is an even function, so that just becomes the secant of theta. Okay, we'll just write that without parentheses. That's the secant of theta, which is equal to 1 over the cosine of theta. And the cosine of theta was 5 over 8. So this becomes 1 over 5 over 8, which is just going to end up being the reciprocal. This is 1 times 8 over 5, which is just equal to 8 over 5. And so that's the secant of negative theta is 8 over 5. Okay, example 2, write tangent in terms of cosine. Okay, so tangent of theta is equal to, in terms of cosine, is equal to sine over cosine, sine theta over cosine theta. And I need to figure out, well, how can I write sine in terms of cosine? Well, sine squared theta is equal, or plus cosine squared theta is equal to 1. So if I solve for sine squared theta, I get sine squared theta equals 1 minus cosine squared theta. If I square root both sides, I have to put a plus or minus there. Then sine of theta equals plus or minus the square root of 1 minus cosine squared theta. And so tangent theta is equal to the top, which is plus or minus the square root of 1 minus cosine squared theta, all over the bottom, which is cosine theta. Okay. Okay, example 3, write 1 plus tangent squared theta, 1 minus secant squared theta in terms of sines and cosines only, and then simplify. Okay, so we have 1 plus tangent squared theta over 1 minus secant squared theta is equal to 1 plus, this is going to become, tangent is sine theta over cosine theta. We're going to square that. Okay, all over 1 minus secant squared theta. Okay, 1 minus 1 over cosine theta squared. Okay. Okay, so this is going to be equal to 1 plus sine squared theta over cosine squared theta, all over 1 minus 1 over cosine squared theta. Now, what I want to do is get a common denominator, cosine squared theta. So I'm going to change these ones into cosine squared theta. Cosine squared theta over cosine squared theta. And so this becomes cosine squared theta over cosine squared theta. Okay, that's a minus sign. And so I'm going to get this equal to cosine squared theta plus sine squared theta all over cosine squared theta all over cosine squared theta minus 1 over cosine squared theta. If I were to multiply both top and bottom by cosine squared theta, then the cosine squared thetas will cancel out. Cosine squared theta plus sine squared theta at the top here. Okay, this just equals 1 according to my Pythagorean identity. That's sine squared cosine squared is equal to 1. So that just equals 1. So that's nice. That's just going to go to 1. Okay, so I end up with 1 over 1 on the top. And then what's the bottom here? Well, the bottom is just going to be 1 over, and this is cosine squared minus 1. Well, if I did sine squared theta plus cosine squared theta is equal to 1, and I wanted to subtract these two, subtract the 1, if I swapped the 1 and the sine theta, the 1 would become negative, so that would give me cosine squared theta minus 1. If I toss it to the other side, the sign changes. And then if I toss the sine squared to the other side, it becomes negative sine squared theta. Okay, so we can see that cosine squared theta minus 1 is equal to negative sine squared theta. And so then this just becomes negative cosecant squared theta. Okay, so this is equal to negative cosecant squared theta. So this is negative cosecant squared theta. Because 1 over sine is cosecant. Okay. Okay, and that's 5.1. I will see you in the next video.